Hello guys, and welcome to video number 164. This video is on sector area and arc length, and the keywords I've got for you are sector, segment, arc, and the key notation is this symbol here. Now a sector is created when two radii join the part of the circumference, which is what an arc is called. So an arc is probably what I should put first there, actually, to be fair, because an arc is part of the circle's circumference. And two radii joining together with an arc creates a sector, a piece of the circle. A segment is created when a chord joins the arc, and that's the part of the circle that we refer to as a segment. And this key notation here is an angle. Okay, so that is the notation that's used for angles, the Greek letter theta, but we refer to it as just an angle in maths. And I'd quite like to just go through with this little space I've got here, just some parts of a circle, because I haven't done a video on parts of a circle. You will get tested on your understanding of parts of a circle at some point, but it's easy to understand through all the other examples I've done. So we've done this one. This circle, or part of the circle, is what we'd refer to as the circumference. Okay, the distance from one side to the other through the center is called the diameter. The distance from the center to the edge of the circle to the circumference of the circle is the radius. Okay, and when you've got two radius, that's called radii. Okay, and these radii joining with this arc, which is part of the circumference here to here, all right, that's a sector. Okay, part of the circle. Okay, this is a sector as well, and this is a sector. There's three sectors that I've drawn here, right? Now, if I join here, so if I go from here to here, right, on this sector, so with a line across here, that is what we call a chord. That line that's gone across here, that's a chord, right? And this part here, that's the space inside it, that's what we call a segment. Okay, get sectors and segments the right way around. People get confused with what they are. And then there's another part of the circle you need to know, which is what we call a tangent. Okay, we've spoken about it before, which is just a line that hits the circle at one point and then goes off in the same direction. Okay, they're all the parts of the circle you need to know the names of, because you might get tested on them. Okay, useful to know in this topic as well. Not all of those are useful, but lots of them are. Okay, so we'll refer to them throughout. Now, to calculate the two separate things to do with sectors, you need to know two different formulae. And the formulae that you need to know are basically the same as the area of a circle formula and the circumference of a circle formula. All right, if you haven't watched the circles area and circumference video, please do. It'll be very useful for you to watch if you don't understand it. Basically, you put the angle out of 360. Okay, it's a fraction of the circle that's being used in each instance. The sector area or the arc length of the sector, okay, it's always going to be a fraction of the whole circle, all right, which is why we use the angle out of 360 and a 360, because a whole turn, a whole circle is worth 360 degrees. Okay, so use the correct one depending upon the problem that you're faced with, and you can rearrange it if you need to. All right, now let's have a look at the first question. A here, got to calculate the area and arc length for the sectors and give our answer in terms of pi. Okay, so if we are going to give our answer in terms of pi, we can still use a calculator if it's on a calculator paper. All right, so I'll bring that in, and I'll just write down area here and arc length here. All right, now this one, the area of this circle can be calculated. If we just go area equals 250 out of 360, because the angle of the sector is 250 degrees, okay, out of 360 times by pi times by the radius squared, which is 3, and that's it. That's all we have to type into the calculator. Now, if it was a non-calculator one, which it could be, you'd get nice numbers. These aren't nice numbers, particularly for non-calculator methods. So I will use the calculator to do this. Multiplied by pi multiplied by 3 squared. And I get 25 quarters of pi, 25 over 4 pi, and the answer then, the units would be in centimeters squared. All right, so I'll just get rid of that, and I'll do the arc length. For this one, the arc length, again, is 250 out of 360, because that's the angle at the center of the sector, multiplied by pi, multiplied by diameter. Diameter is 2 lots of the radius, so that's 6. Okay, and then that's a nice easy one to do as well. So I could literally just go in and change that to a 6. All right, 25/6 of pi. and that is in centimeters because it's a length and not an area. All right. Now that's A done in terms of pi. Let's do B. All right, and there's not really too much different here other than the fact that we've been given the angle on the outside, the reflex angle on the outside of the sector. We want the angle that would be on the inside of the sector there. So the angle that we would use for B, and I'll write it in the middle again, area equals 130 out of 360, and we're using that because 360 minus the 230 equals 130 degrees. Okay, and then we multiply that by pi, multiply it by the radius squared, so that's 12 squared, right? And this time it's in millimeters squared for the answer. So area equals, and then we'll just bring the calculator in again to do that. 130 out of 360 multiplied by pi multiplied by 12 squared, 52 pi. Millimeters squared. Arc length equals, very similar thing, slightly different formula. All right, so the arc length, let's just type it in. All right, get rid of that. It's the fraction multiplied by pi multiplied by diameter. Diameter would be 24. Okay, so let's put the number 24 in there and get the answer, 26/3 of pi. Millimeters. All right, squeezed it in, but there you go. Fairly simple stuff. Once you know you're allowed to use those formulae, it's relatively easy. Okay, let's have a look at the slightly more complicated problem that we've got in number 2. 2 parts to it. We've got to calculate the radius of the sector. So we have to find what the radius is. Got rounded to 2 decimal places, and we've been given the area. If we weren't given the area, we wouldn't be able to find out what the radius was. Okay, and we're allowed to use the formula again. So we've got the angle at the center there, so 150 out of 360. Multiplied by pi, well that's just a number. This part here is just a number. Multiplied by the radius squared, that's x squared. Right, just instead of putting r squared, I'm using x because that's what that we've been given there. So x squared is equal to the area. That's the formula for the area of a sector. So the area is 105.78. All right. Now, if I think of this as being just a number, which I said it was, right, that's just a number that's in front of x squared. And what we can do is divide by that number on both sides. So just get this over here a little bit and type in what we need to. So 105.78 is the area. Divide by, now let's be careful with this as well. Let's put that in brackets. 150 out of 360 multiplied by pi, and then close that bracket, because what the calculator is doing here is doing this calculation for me, and then it's dividing by, we're dividing into 105.78, right, and I'm getting 80.80. So what I've got left on this side is x squared, 80.80 I think it was, 809, and some other numbers. Now, if I want to get the x here, the x value, which is the radius, remember, I have to not divide, I have to square root both sides. Okay, square rooting is how you get rid of the squared value of x. So I'm going to square root the answer. Now I'd get 2 solutions here, and I'm going to ignore the negative one. All right, so square root of the answer equals. Now I'm ignoring the negative version of that answer because lengths can't be negative. Okay, so rounding that to 2 decimal places, the radius equals, or x equals 8.99 centimeters. All right, now in part B, we can calculate the perimeter of the sector using what we found in part A. All right, and we'll do that by a nice process of trying to get it all done in one go on the calculator. So 150 out of 360 would be the starting off of the formula, multiplied by pi, multiplied by diameter, right? So I'm going to put multiplied by 2 lots of the answer. I'm just going to put that in brackets, multiplied by 2 times the answer, because I don't want it to round anything at the moment. So I'm going to put that in there, and then I'm going to close that. Now, what this would do in this big square brackets, it would work out the arc length, okay, from here to here, around the curved bit here. But what I want is the perimeter, which is a bit different, right? All I've got to do is add on this and this. Well, we know what x is, all right? And we know that this is the same thing. That's x as well. Okay, so x plus x, 2 lots of x. So plus the answer on the outside of the bracket there, plus the answer again, would give me the perimeter of that sector. Okay, so this big square brackets is going to give me the arc length, right? I'm using the answer that I got from the last question to do that, and then I'm adding on the diameter, right? I could have done 2 times the answer there if I wanted to, but I just thought it'd be easier to understand, right? Answer plus answer. So I've gone from here to here, it's in the square brackets, then here plus answer plus answer. Right, now type that into the calculator, it gets done in one go. And yeah, let's just get a bracket up there, put in 150 out of 360. Go multiplied by pi, multiplied by, and then another bracket, 2 times the answer that I got from the last question, and then close that bracket. Brings up a big bracket there, plus the answer equals 41.51 centimeters. There you go. All right, so much trickier than the first questions, but definitely something you could be given, grade 5 stuff, at Foundation GCSE. Let's move myself over, have a look at the third question. Now I think that I've written this one, and I think this one is probably more like a higher level question, but you could technically get it on a foundation paper. So don't panic too much. I mean, this would be real top end stuff here of grade 5. But it did used to be a grade 7 topic. Or an A grade topic before they changed the gradings to numbers, right? So it was A grade maths, and this is probably why it was A grade maths, this particular question. But it's basically working backwards what we did in question 2b. All right, so we've got a sector that's got a perimeter of 103 centimeters and a radius of 40 centimeters. We've got to find the area of the sector. Now, what would be useful is if we had a sketch of a sector, and I'm just going to sketch a sector there and say that that is what it looks like, right? It's an awful sketch, I know, right? You probably could do a better one than that. And then we can label the things we know. We know that's 40 centimeters radius there, right? We don't know the angle, so we could put angle symbol, theta, all right? And we know the perimeter, the whole distance around, is 103 centimeters, all right? So we can just start filling in some things, all right? We know the diameter, all right, because we're going to need to know that. The diameter is 2 lots of the radius, so that's 80 centimeters. Just write that next to it. Right. So let's start the calculation. Let's start the thing that we need to do. The angle at the center of the sector out of 360 multiplied by pi multiplied by the diameter, which is 80. Okay. And then put that in a big bracket like that. And then add on 80 equals 103. Because that's the perimeter, all right? So this is the same thing as what I did in question 2b, all right? Except I don't have the angle. We're going to need to find the angle in order to get the area of the sector. We have to have that. I think I mentioned that earlier. And if I didn't, I'm sorry. I just assumed you would know, all right? But that's what we're looking for. We're looking for that angle. Then we can calculate the area. So I'm going to take away the 80 from both sides of this. And that's going to give me 23. And then I've got angle out of 360 times by pi times by 80. All right. Now all of this is, because it's all times together, that and that and that can be put together on top of 360. So I'm going to call that 80 pi angle. All right. 80 pi angle out of 360 equals 23. Right. Then I'm going to go up there with my working out. Right. This is now equations. We're solving some equations here. All right. So I'm going to get my calculator in. And I'm going to clear all that because that was nothing to do with this question. I'm going to put in 23 multiplied by 360. And that leaves me with the 80 pi and the angle. 80 pi times by the angle equals 8 to 80. All right. Now I'm going to divide by the 80 pi. That leaves me with the angle. So the angle equals, now I've got to be careful here, because this is the second time I've done this video, and before the calculator didn't do this bit properly because it's an old calculator, right? My new calculator would do it properly the way that I did it on here. This old calculator doesn't, so I have to be really careful. So I'm going to take the answer and I'm going to divide by, and then I'm going to put in brackets 80 pi. All right, and I didn't put brackets in last time. And there you go, 32.94. Something, something, something. All right, that is the angle at the center of this sector. Now, once I've got that, that's really important I have it. I can now work out the area. So the area is that answer out of 360 multiplied by pi multiplied by the radius squared, which is 40. All right, so 40 squared. That calculation there is going to get me the answer to the area of the sector. So it's a nice simple end to this question, but getting that is really quite complicated, I think. Multiplied by pi, especially for foundation maths, multiplied by 40 squared. There we go. Is that correct? So that's the answer that I used out of 360 times by pi times by 40 squared. That is 460. That seems like a lovely answer, doesn't it? 460, and then that would be in centimeters squared. All right, because it's an area. That's it. All right, really tricky. Like I said, used to be a lot more the grade A stuff. All right, it's moved on to foundation. Might not get that sort of question. You're definitely going to get these sorts of questions in number 1. Probably get number 2. But this might be left for a higher paper, who knows. All right, so please do like, subscribe, click the link in the description. Thanks for watching this one all the way through onto the end of it. It's a tricky topic. Oh, don't know where I'm going there. Let's see. Yeah, just needed that back. Quite a long video. Thanks for sticking with me. Like I said, please do watch some more. But just take it one step at a time. Don't watch all these in one go. Otherwise you won't remember things. All right, it's all about the practice. Take care of yourselves. Ta-da. See you in the next one.